exercise, okay, is quartic and other polynomials. So I don't think it's actually a new thing. It's just a little bit extension after cubic. So it's exactly doing the same thing for quartic, okay, compared to quartic compared to cubic. So first we think about the graph. Okay, graph. How many type of graph we have for cubic? There are two types of the graph. One type is ax minus h cubed plus k, and the other type is ax minus a, x minus b, and x minus c. Okay, fully factorized one and or in the ax minus h cubed plus k form. So the graph one looks like this, and the other one looks like this. Okay, so that's for cubic. Quartic is the same. There are two types of the equation. So first type is x to the power 4 is the simplest form, and this form you have a graph looks like this, and this graph, okay, is very similar to quadratic. Okay, it's very similar to quadratic. If I sketch this quadratic on the same set of x-axis, not very satisfied. You have a graph looks like this. They intersect at negative 1 and 1, 1 and 1. Okay, that's the point of intersection. 1, 1, negative 1 and 1. They intersect here and also intersect at 0, 0. Okay, so in between, okay, I make this graph larger. In between negative 1 and 1, the blue graph, which is x squared graph, is on top of x to the power 4 graph. Okay, so in between negative 1 and 1, the quadratic is above the quartic, and to the left of negative 1, to the right of 1, the quadratic is actually below the quartic graph. Okay, so that's like if I put them on the same set of x-axis, the relationship between them will be that. But like the shapes are very similar. Okay, the shapes are very similar. The difference will be like it's quite flat at the bottom for the quartic, and it's quite sharp, like small for the quadratic. Okay, so the feature is still have like the feature will be exactly the same as the quadratic. Turning point at 0, 0, domains are ranges r plus union 0 or 0 to infinity. Okay, the general equation. Okay, the important thing here is the general equation. The general equation fx equals to ax minus h to the power 4 plus k. Very similar to turning point form. Okay, and also the cubic one. Okay, to the power 4. So how we can sketch this graph? Okay, how do you sketch the quadratic by using turning point form? How you will sketch this type of graph? Okay, so the turning point is h comma k. Okay, the turning point is h comma k. And if a is positive, the graph will be happy face, like upward, and if a is negative, will be the sad face, is facing down. Okay, inverted. So you know the turning point, you know the shape of the graph, and you can find x-intercept, y-intercept, and you can sketch this graph. Okay, so let's have a look at this example. You have x minus 2 to the power 4 minus 1. Okay, so first of all, you have turning point at 2 comma negative 1. That's how you find the turning point for quadratic. And now you know that the shape will be this shape because the a value is positive. And then you will say when x equals to 0, y equals to 0 minus 2 to the power 4 minus 1. Y will equals to 15. Negative 2 to the power 4 will be 16. 16 minus 1 will be 15. So 0, 15 is the intercept. And next is when fx equals to 0, x minus 2 to the power 4 minus 1 equals to 0. X minus 2 to the power 4 equals to 1. Okay, question is, what x minus 2 equals to? What x minus 2 equals to? 1 or plus minus 1, okay? Because that's an even power, when you take the square root for both sides, you need to plus minus that. So it's plus minus the fourth root of 1. Then x equals to 2 plus minus 1. Then x equals to 1 or x equals to 3. So 1, 0 and 0, 3, 0. Okay, so the information you have now is 0, 15, 1, 0, 3, 0, and the turning point at 2, negative 1. Okay, let's sketch this graph. Have y here, have x here. Okay, you have 0, 15, which is here, and you have 2, negative 1 is the turning point. 2, negative 1 is the turning point, and you have 1, 0 and 3, 0. 1, 0 is here, 3, 0 is here. Well, if I sketch this graph, the graph will look like this. You have 3, 0, 1, 2, negative 1, and this one is 1, 0, and here is 0, 15. So that's the shape of the graph. Because the 0, 15 make the scale a little bit weird, so shape not looks very nice. But that's the actual graph. That's the actual graph. Okay, have a look at the next one. Have a look at the next one. What's the turning point for this one? What's the negative 1, 4? Yes. And then when x equals to 0, y equals to negative 2, 1 to the power 4 plus 4. Negative 2 plus 4 equals to 2. So 0, 2 is the y-intercept. And when fx equals to 0, minus 2x plus 1 to the power 4 plus 4 equals to 0. 2x plus 1 power 4 equals to 4. X plus 1 to the power 4 equals to 2, 4, and that equals to 2. So what's x plus 1 equals to? Anything else? Plus, minus? Okay, don't forget plus, minus. I think you're doing well on square root now, but like any even power, you will have plus, minus there. So x equals to minus 1 plus minus fourth root of 2. Okay, so you have x equals to minus 1 plus fourth root of 2 and x equals to minus 1 minus the fourth root of 2. This one must be negative. How about the top one? Negative or positive? This one is negative. How about the top one? Is that positive or negative? Positive. Positive or negative?
It's negative. Positive.
Oh my god. It's positive. Make sure now. Okay, it's positive. Why is positive? Because fourth root of 2 must be greater than fourth root of 1. Okay, that is 1. So 1 is smaller than this number. If 1 is smaller than this number, that number, let's say, is 1.1. So negative 1 plus 1.1 will be positive for sure. Okay, so that's a positive number. So you don't need to know how large is actually this number is, but you need to know whether it's positive or negative. All right, let's sketch the graph. Okay, you have -1 and 4. Have 0 and 2. Okay, you have those 2 points. Make sure that those 2 points is symmetrical about the line x equals to -1 because it's like same as quadratic, so it must be symmetrical. Okay, the 2x intercept must be symmetrical about x equals to -1, which is the turning point. Okay, the turning point. So the graph will look like this. Because it's a -2, so the shape will be a like inverted shape. You have -1, 4, you have 0, 2, you have -1 plus 4√2, 0, and you have -1 minus 4√2, 0. Any question about those 2 graphs? That's the first type of the graph, like how you sketch with this form. Okay, a times x minus h to the power 4 plus k. Okay, next page, please. How many pages do you left? Okay, next page. Have x to the power 4 minus 8x equals to 0. You're trying to solve for that. Okay, for any polynomial question you want to solve, factorize first. Okay, that's always the first thing, factorize. Doesn't matter if it's cubic or quartic or like degree of 5. You always factorize first. So to factorize that is x is the common factor. So first you always check, is there any common factor? Okay, now you want to factorize a cubic. Okay, you are very familiar to factorize cubic. How do you factorize this cubic? How do we factorize this cubic? We have a couple of types of cubic like we factorize. We can use grouping methods. We can try a number to find a solution for that. Well, and we also have the formula a cubed minus b cubed, right? A cubed minus b cubed. Okay, don't worry, that's obviously a cubed minus b cubed. I'll tell you one method. If you totally forget this formula, what you can do. Well, x cubed. You can do long division, but it's not. Okay, still use this box. You have x cubed. Okay, you have this x cubed. So you have 1 x cubed, you have 0, 0, 0. Okay, 3 zeros there. But you need to keep the position there. You have x squared term, x term, and constant term. So 4 box. What answer you can see for this one? Like one solution. What value can 2? Okay, 2. So let's put 2 here. So you have 2, 1. Yep. Which number? Yeah, a -8. Sorry, a -8. I have 1 and 2, and that's 2. 4, that's 4, and that is a 0. Okay, you can still use this box to factorize this. So you have x minus 2, x squared plus 2x plus 4 equals to 0. Or if you know the formula is a minus b, a squared plus ab plus b squared. Okay, better if you can remember this formula. If you can't just use this box, you still can find out the solution. And And this discriminant is b squared minus 4 times 1 times that. That's smaller than 0. No solution for that one. Can't further factorize. Therefore, x equals to 0 or x equals to 2. Okay, that's the first one, which is easy. Have a look at the second one. X to the power 4 minus 8x squared equals to 0. What's the common factor you can see here? 2x squared, good. So I have 2x squared, have x squared minus 4 equals to 0. 2x squared, x plus 2, x minus 2 equals to 0. Therefore, x will be 0 or x will be plus minus 2. There are actually 4 solutions. 0, you have 2 0 as solutions. X squared, you have 0, 0. Okay? But you only write 3. Okay, the next one. X to the power 4 minus 2x to the power 3 minus 24x squared equals to 0. What's the common factor? What's the common factor? X squared. And you have x squared minus 2x minus 24 equals to 0. X squared 20 minus 24 want to make a 2, you have 4 and 6. Okay, 4 and 6 can give you a 2. You need a negative 2, then you need a negative 6. That equals to 0. Then x equals to 0 or x equals to minus 4 or x is 6. Okay, those 3 questions are easy. Let's have a look at the next one. Next one is solve the following inequalities. Okay, solve the following inequalities. If you want to solve inequality, it will be the same unless it's a linear inequality. You still need to sketch this graph. Okay, but the problem is how do you sketch graph for quadratic? Okay, how do you sketch graph for quadratic? We learned in the previous page that the particular form, how we sketch it, it looks like a quadratic. But let's see for this one how we are going to sketch this. First, we will factorize it first. Okay, factorize. So you have let's put minus that plus 2x cubed plus 24x squared in the decreasing order. Okay, we always want to see things in the decreasing order. Minus 4x cubed plus 2x, minus 4x to the power 4 plus 2x cubed plus 24x squared. And minus x squared will be the common factor. So you have x squared minus 2x minus 24. Okay, that's what we factorize on the top, I think. And you have that. You have x minus 6 and x plus 4. Okay, 24 amount to make 2, negative 2. So it's negative 6 and 4. Okay, how do we sketch cubic? Do you remember? After we factorize, what we need to do? How do we sketch cubic? Well, after we factorize the equation, what's the next thing we do? Find intercept. Okay, find intercept. So let's still find the intercept when fx equals to 0. Then x will equals to 0. You have 2 zeros actually, and you have 6 and you have negative 4. let's label those points. You have 0, 0. You have 6, 0, and you have -4, 0. Okay, tell me if you have two repeated solution in cubic, what that point will become? Turning point. So that will still be a turning point. It still be the same as what you do for the cubic. And you have y-intercept is 0, 0 as well. And what's the next thing? Shape. Okay, where do you start your graph? Do you start at the right bottom or right top? Okay, you will start at right bottom because the leading term is negative. Okay, the leading term is negative. You will start from the bottom. Okay, start from the bottom here. You go up. You go like, well, start from the bottom, and that's a turning point. So it will turn like this, and you will go down again. Okay, like that. That's roughly the shape. I will do a better one. So. Okay, that's the graph. That's 6, 0, minus 4, 0, 0, 0, and the turning point, I don't know where's the turning point, but like the shape is like that. If that's the shape, I want fx greater or equals to 0. Can you see I want the fx greater or equals to 0. If that's greater or equals to 0, I will start from this point. All of those graphs until here will be acceptable. Okay, it's all above the x-axis. Then I want to see what is the corresponding x values. All of those x will be the corresponding x values. Therefore, x will belong to start from -4 to 6. Start from -4 to 6. Okay. You find the shape. You label where's the required point, required graph, and find the corresponding x values. Okay. That one is easy to factorize. Let's have a look at the next one. The next one is 3x to the power 4 minus 13x squared plus 4. It's not that easy to factorize because there's no common factor. I can't reduce it to a cubic. So what I will do for this one. So for cubic, we'll find a number to make fx become 0. So for quartic, it will be the same. We're trying to try a number to make it become 0 as well. The number wants you to try is still the same. Plus minus 1, plus minus 3, plus minus 1, plus minus 2, plus minus 4. Those numbers are the numbers you should try. Okay, so it's a quartic. You have x power 4 to 3 to 2 to 1 and to constant. You should have 5 or 6 columns plus the initial column. So you should have 1, 2, 3, 4, 5, 6. Okay, x to the power 4, you have 3. Let's write that in black. Okay, 3. X to the power 3 will be 0. X to the power 2 will be -13. X term will be 0 and constant term will be 4. Okay, 5 numbers, 2 placed with 0. And let's think about the number we start to try. Okay, let's try 2. 1 is not working. Can you see 1 is not working? If you have 1 is 3, 13, and 4, it's not going to make a 0 for you. So let's try 2. Okay, I believe you can try 2. Have 3, and that's a 6, 12, 12 minus 13 minus 1. 2 times minus 1 minus 2 minus 4 plus 4 0. Yes, okay, we have the correct number. So let's write fx. Well, let's write fx here. Fx equals to x minus 2. Okay, it's a quartic, and then you take a linear out. What has been left? What's the next equation? Cubic. Okay, should be a cubic. So it's 3x to the power of 3 plus 6x to the power of 2 minus x and minus 2. Okay, that's the what has been left. And that's a cubic equation. You need to further factorize it until find another linear factor until it's a quadratic, right? You need to keep going on. You want to find another linear factors for this cubic, and then you want to find a quadratic and factorize that quadratic. So what's the good thing for this box is I can create another column, another row. Okay, and I don't need that box. I don't need that box. And I use those 4 numbers. Treat them as a cubic and keep doing. Okay, if you set up another box, you have 3, 6 minus 1 minus 2, which is exactly the thing in the red box. Okay, you use that one as the new number and to try another number. Okay, let's try another number. Negative 2. Okay, let's try negative 2. I'll use green to try that. Negative 2. Okay, the 3 will come down. Negative 2 times 3 will be 0, 6, negative 6. Negative 6 plus 6 will be 0. 0 times negative 2 will be 0. 0 plus negative 1 will be negative 1. Negative 2 times negative 1 is 2. 2 minus 2 will be 0. That is the remainder, and that is 0. Okay, that is 0. So what I have now is fx equals to x minus 2. And then in this cubic, I have x plus 2. 3x squared minus 1. Okay, minus 1. Then 3x squared minus 1 is 3x squared minus 1 on 3. And then that's 3x squared minus 1 on, let's say, root 3 over 3 squared. Okay, 1 on root 3 is root 3 over 3 after you've rationalized the denominator. And you have 3 times x plus root 3 over 3 and x minus root 3 over 3. So fx equals to 3, x minus 2, x plus 2, x minus root 3 over plus root 3 over 3, and x minus root 3 over 3. Therefore, when fx equals to 0, x will be plus minus 2, x will be plus minus root 3 over 3. Okay, one thing I want to say here. At the beginning, you're not going to try 1 because 1 obviously not going to be a solution. Then after you reduce that to a cubic, you are not going to try 1 or negative 1 either. Okay? Because if it's not a factor here, it's not going to be a factor for this one. Okay? So you don't try 1 here, don't try in the next row. Okay? Then what's the y-intercept? The y-intercept will be 0, 4. Okay, from here, 0, 4. And we can sketch this graph. Zero, 4. Okay, plus minus 2. Okay, plus minus 2. And you have root 3, plus minus root 3 over 3. You don't know how large is that, but like it's obviously less than 1. Okay, obviously less than 1. Root 3 over 3 is less than 1. So let's say it's here and here. But it's symmetrical about 0, right? It's symmetrical about 0. Go right for that much unit, go left for that much unit. And do you think this graph will start at the top or start at the bottom? Top right or bottom right? Top right. My God, this shape was so difficult to sketch. It's a W shape. Yeah, they should be symmetrical because it's a quartic. Well, not for all the quartic. For example, this one. This one is not necessarily the turning point in the middle. Okay? But like for this W shape, because all the x-intercepts are symmetrical and also this is symmetrical as well. So that shape will be a perfect like symmetrical shape. Not all of them. Not all of them. It's only in this case. That is 2, 0, root 3 over 3, 0, negative root 3 over 3, 0, and negative 2, 0, and 0, 4. What I want to have is fx greater than 0. fx greater than 0, not equivalent to 0. Greater, okay, is here, not including that point. Greater is here, not including those 2 points. And here, not including that point. So what's the corresponding x values? The value here, here, and here. You can see those red graph is corresponding to those green bits. Okay, so I can write x belongs to negative infinity to the point negative 2, open like round bracket, not including negative 2, union negative root 3 over 3, 2 root 3 over 3, round bracket, union 2 to infinity. Okay, that will be the shape. Okay, so in this page, we have learned how to factorize quartic, how to sketch graph for quartic, and how to solve inequalities for quartic. And let's go to, okay, I'm not going to do page 67. I will talk about the even and odd function after we finish that. Page 68, please. I want to go through example 6 first. Because it's inequality as well. Because it's inequality as well. Well, that's quite important. So what you want to solve is fx smaller or equals to gx. Then what you want to solve is x to the power 4 smaller or equals to 2x to the power 3. But I don't want equations on both sides. I want one side to be 0. Okay, right hand side to be 0. Therefore, I can have x to the power of 2 minus 2x to the power of 3 smaller or equals to 0. Now we have some equation less than or equals to 0. And what I'm trying to do is sketch that function. Okay, sketch that function. So how I can sketch this one? What's the common factor for this function? X cubed, yeah, x to the power of 3 and have x minus 2 smaller or equals to 0. Let's say that function is hx, and I want to sketch hx. When hx equals to 0, x will equals to 0, 0, 0, and 2. We have 4 factors, 3 of that is x, we have 0, 0, 0, and 2. How many 0 you have? 3, right? What that point will become? Point of inflections, okay? When I say the turning point and I tell you if it's like odd number of times of the solution, you have point of inflection there. So that 0 point will become a point of inflection. Okay, let's have a look at what the graph looks like. Oh, it's too big. Okay, the 0, 0, 0 will become point of inflection. That's a point of inflection, and I have 2 zeros, which is here. It's a normal intercept. I should start at the top or I should start at the bottom? Top. Okay, everyone, the graph should start at the top because it's x to the power 4 is the leading term and it's a positive leading term. Okay, start from the top. Go through that. Okay, I will go through that point as well, but that point is a point of inflection. So the graph is this shape. Okay, it still go past through that point, but that how you go past through that point, that is a point of inflection. Okay, that is a point of inflection. And what do I need? I need x smaller, or like I need this value to be smaller or equals to 0. So therefore, I will have this part of the graph. And the corresponding x will be here. Okay? So x should belong to 0 to 2. Okay. The point of inflection is important. That's the point of inflection and go past through another point. That's the shape of this graph. Okay. Even though if you just go directly across this, not showing point of inflection, the graph is wrong, but the answer will still be the same. Okay, the answer will still be the same. Not going to change your answer. But I think it's good if you know the shape of this graph. Okay, point of inflection. If it's like a 5 solution at 0, it's still a point of inflection. Same thing like this. Okay, so you have 4 solutions, you have to be a turning point. Okay, 7 point of inflection. So how do you sketch polynomial? It's all the same. Factorize this polynomial, doesn't matter what's the degree of this polynomial. Find all the x-intercept, find the y-intercept, decide to start at the top or the bottom. It depends on the leading term. And then find the shape of the graph. Even number of solutions have turning point, all number of solutions have point of inflection. Okay, so that's how you sketch. Okay, that's example 6. Okay, do one last thing. That is the even and odd function. So what is an even function? What is an odd function? Okay, I'll tell you if you know the graph. Even function is the function that is symmetrical about y-axis. Okay? Symmetrical about the y-axis. That will be an even function. Okay, now the thing is, if you don't know the graph, how you can like say it's an even function or not? You will use this. Oh, it's not that. You will use this formula to test it. If you substitute the negative value, that will be the same as you substitute the positive that value. Then that function will be an even function. Okay, so that's how you say it like without the graph. Okay, if with the graph, you can obviously see if the graph is symmetrical about the y-axis. If it's symmetrical about the y-axis, yes, it's an even function. But if you don't have the graph and you don't know the graph, you can test about this equation. Okay, I'll show you the example in a minute. And the odd function, what's the odd function? Is symmetric about the origin. Okay, symmetric about the, not symmetric about the x-axis. Okay, it's symmetric about the origin. So what's symmetric about the origin? That graph is symmetric about the origin. Okay, if you turn that like about 180 degrees, that will be the same. Like, can you see that? Like, symmetric about the origin. So basically is this part of the graph reflect by x first and then reflect by y-axis. Okay, so this part of the graph reflect by x and reflect by y. You will result in this graph and that's symmetric about the origin. So again, if you don't know the graph, how you will know that? If you substitute a negative value, that value you achieve is the same as negative of the value substituted as the positive. Okay, it equals to negative of the positive value. Well, like I'll show you the example how to do this. Like that's the two formula and that's the two type of graph you have for odd and even function. Okay, let's think about this. State whether the following polynomials is even or odd. Okay, both formulas are about f negative x. Okay, both formulas are about f negative x. You want to know what f negative x will give you, and then you can say the function is even or odd. Okay, some function can be not even nor odd. Okay, for example, if you have a graph like that, that's not even or not odd. Okay, not necessary to be either even or odd. So let's have a look at fx. My interest is to know what f negative x is. Okay, what f negative x is. So I will say what f negative x for this is 6 times negative x to the power of 4 minus 3 negative x to the power of 2. Okay, that's f negative x. And what's f negative x? Negative x to the power of 4 will give you x to the power of 4. That's 6x to the power of 4 minus 3 times negative x to the power of 2. That's x squared. You have 3x squared. No. Okay, f negative x is that. And let's have a look at this. Okay, this bit is exactly as this bit. You see that equivalent to that? Then what you can say is, okay, that is equivalent to that. And that is fx. So you will say f negative x is actually equals to fx. And that is an even function. That is an even function. Okay, the next one. You're still interested in what this negative x gives you? Then g negative x equals to 3 negative x to the power of 5 minus negative x to the power of 3 plus negative x. Okay, negative x to the power of 5, what that is? Negative x to the power of 5. So it's negative 3x to the power of 5. What negative x to the power of 3 gives you? Still negative, right? Negative x cubed. But you have a minus in the front, that is a plus x cubed. And n plus negative x is a minus x. So your g negative x equals to that. Okay, let's take a negative sign out. That's a negative 3x to the power 5 minus x to the power 3 plus x. And you can see that is equivalent to that. So you will say g negative x is equals to negative gx. And that is an odd function. Okay, that is an odd function. So always interesting.
Here, let them each make now be grass area and be Here, let them each now be held and the unblock be the grass area.
Okay, everyone, let me finish this. 2 more exercise. Let me finish. Okay, h negative x is negative x to the power of 6 minus 3 negative x to the power of 2 plus 2. So h negative x equals to negative x to the power of 6 will give you x to the power of 6 minus x squared will give you x squared. So that's a 3 minus 3x squared. And you have the plus 2. That is exactly the same as this one. So you say h minus x equals to hx. And that is an even function. Can you see, even though the original function contains a constant here, but that doesn't change. It still can be an even function. Okay, but the old one will be a little bit different. Have a look at number 4. Have a look at number 4. M negative x will equals to negative x squared plus negative x. M negative x equals to x squared minus x. M negative x equals to negative bracket negative x squared plus x. Okay, none of either this or this is not equivalent to that. So this mx negative x is not equals to fx. This m negative x is not equals to negative fx. Okay, it's not equals to both of that. So it's neither even or odd. Okay, it's neither even or odd functions. Okay, I want to have one more here. Let's say nx equals to x to the power of 3 plus x plus 1. Let's predict, what do you think this function will be, even or odd or neither even or odd? Odd? Okay, let's have a look. What's a negative x? That's negative x to the power of 3 plus negative x plus 1. And negative x equals to negative x to the power of 3 minus x, but it's still plus 1. Okay, you still have the plus 1. The constant doesn't change signs. Okay, so n negative x is not equals to nx. N negative x is not equals to negative nx. Because of what? Because of that constant. Okay, because of that constant. So that's neither even nor odd. number 3, you have the constant, and it still can be an even function. But you have constant here. If without that constant, that must be an even function, odd function. Sorry, odd function. But you have the constant there, that cannot become even function anymore. Okay? So for even function, yes, you can have the constant. For odd function, you won't have constant at the back. If you have constant, that cannot be an odd function at all. Okay, that's everything for this exercise. Okay, that's 6i. I have skipped a little bit the power function, but the power function will be teaching year 12 more clearly in a more clearly way. So let's just skip this part and I have finished all the rest. Okay, I finished all the rest.